This is the most powerful space telescope ever built, and when it launches later this year, it will show us things that we have never seen before. It's also been suggested that this new telescope could prove there are planets everywhere. We really can't wait for it to launch. So let's take a look at this amazing telescope and what it will be used for. This is the incredible Nancy Grace Roman Telescope. It was previously called the Nancy Grace Imaging X-ray Telescope, or the LXS, but NASA recently decided to change its name so that it wouldn't be confused with another upcoming mission called the LISA X-ray Telescope. The Nancy Grace Roman Telescope has been under development for nearly 10 years now and is the successor to the famous Hubble Space Telescope. The telescope is huge and slightly strange looking. Its main mirror is made up of 18 hexagonal segments, just like the James Webb Space Telescope. But unlike the WFIRST, the Nancy Grace Roman Telescope is much closer to Earth. It will orbit our planet at around 720 miles above the surface, which is only about 1/8 of the distance from Earth to the Moon. This means that the telescope will be able to quickly return data to Earth. The Nancy Grace Roman Telescope will do things that no other space telescope has done before. It will measure dark energy, look back in time to see the first galaxies form, and search for biosignatures on exoplanets. But this isn't why people think it's going to revolutionize astronomy. There's something else that everyone is excited about. Before we get into this, let's take a look at the telescope's instrument. The primary instrument is the 1600 pixel wide field instrument, or WFI. It's an incredibly advanced camera that can detect visible light, near-infrared light, and a small amount of ultraviolet light. It will be able to see objects that are much dimmer than Hubble could. The WFI also has a special feature that no other telescope has. It can take two images very quickly and then combine them into one extremely sharp image. This is known as the Roman Super Resolution, or FSR capability. It works because the telescope can move itself extremely accurately. It can move down to the level of individual atoms. In fact, when the telescope is in operation, it can move 3 nanometers every 10 milliseconds. That's about 10 times faster than any other space telescope. When it moves at this speed, it makes a tiny wobble in space. However, the telescope has a gyroscope on board that stops it from spinning out of control. The FSR technique basically takes advantage of this wobble by moving the telescope at super speed and taking 2 images in quick succession. They are slightly different because the telescope moved during the time between the exposures. By combining these 2 images together, the result is one highly detailed picture. This won't work for everything that the telescope looks at. For example, if you were looking at stars, they would appear twice in the image. Once where they actually are, and once where they were when the telescope moved. But if you were looking at something like a nebula, you would get an extremely sharp image of it. The FSR technique is said to be so good that it will reveal details as small as 100 meters across on objects that are 115,000 light-years away. For comparison, that's like being able to read a phone book at the other side of the United States. The second instrument on board the Roman telescope is the 100 millisecond high-resolution channel, or HRC. It's basically a smaller telescope within a telescope that is mounted in front of the main camera. It will allow the Roman telescope to take extremely accurate measurements of objects that are in our solar system and nearby stars. Unfortunately, the HRC won't be operational when the telescope launches. There are some problems with the instrument that need to be solved before it can start working properly. Now that we know how the telescope works, let's take a look at what it will be used for. One of the main goals of the Roman telescope is to study dark energy. Dark energy makes up around 70% of the energy in the universe. It's the thing that's causing the expansion of the universe to speed up. We don't know what dark energy is, but we do know that it exists. The Roman telescope will measure the rate at which distant supernovae are accelerating. This will help scientists learn more about the nature of dark energy. Another goal of the Roman telescope is to look back in time to see the formation of the first galaxies. The Roman telescope will be able to see further back in time than any other telescope. This will allow scientists to learn more about how the universe evolved after the Big Bang. The Roman telescope will also be used to hunt for signs of life on exoplanets. The telescope will measure the atmospheres of planets outside of our solar system and look for the presence of biosignatures. These are chemical signs of life, such as oxygen and methane. If the Roman telescope finds signs of life on an exoplanet, it would be one of the most important discoveries in history. But these aren't the reasons that everyone is excited about the Roman telescope. There's something else that astronomers can't wait to try. Now that we've looked at the science behind the Roman telescope, let's take a look at the upcoming launch. The Roman telescope was originally supposed to launch in 2027, but it was delayed due to technical issues. It's now scheduled to launch in 2026. The telescope will be launched on a United Launch Alliance Falcon 9 rocket. It will take off from the east coast of the United States and will reach space in around 10 minutes. Once in space, The telescope will unfold and then it will travel to its final destination at Lagrange point. 2. This is a spot in space that's 1.5 million miles away from Earth. The telescope will stay here while it operates and will take measurements of dark energy and the early universe. The mission is expected to last for at least 5 years, but hopefully it will last for 10 years or more. So what is everyone excited about? Well, in 2024, the Roman telescope will start its survey of the sky. It will take images of billions of stars and galaxies and make measurements of their positions and brightnesses. This survey will cover a patch of sky that's 10 billion light-years across. But here's the thing, the telescope won't be looking at empty space. It will be looking through space. Everything that's in our universe is made of atoms, and atoms interact with light. This means that there is no such thing as empty space. Even if the Roman telescope is looking at a region of space that appears to be empty, it will still be able to detect things in that space. Atoms that make up stars, galaxies, and planets will be moving around. They will be vibrating, rotating, and interacting with each other. All of these things will cause tiny disturbances in the fabric of spacetime, and if the Roman telescope is sensitive enough, it could detect these disturbances. In other words, the Roman telescope could detect the music of the spheres. This is the idea that the universe is full of music, and that this music is the key to understanding the universe. Some physicists believe that the universe is a hologram, and that everything we see is just an image projected from a higher dimension. If this is true, then the music of the spheres should be audible to those who listen closely. So could the Roman telescope really prove that there are planets everywhere? Well, yes and no. Yes, because the universe is full of stars, and most stars have planets. It's also likely that most of these planets are habitable. However, just because a planet is habitable doesn't mean that it has life on it. And there's no guarantee that life will evolve on any of these planets. No, because even if the Roman telescope detects the music of the spheres, it wouldn't prove that there are planets everywhere. It would only prove that the universe is full of music. What do you think? Is the Roman telescope really going to find planets everywhere? Let us know in the comments below. And don't forget to subscribe if you haven't already. Thanks for watching. We hope you learned something new and exciting about the universe. If you want to learn more about the universe and the amazing things that we discovered about it, then be sure to check out our other videos. We're always coming out with new content, so there's always something fresh to learn. Until next time, keep looking up.